So now we're going to look at number 5. We have a spherical balloon and air is being pumped into it, so the volume is increasing at a rate of 100 centimeters cubed per second. So that means that I have V dt, is equal to 100 centimeters cubed per second. Let's write that nice, dV dt. So I have the rate that the volume is increasing as air is going into it. It wants to know, so it wants, how fast is the radius increasing? So it wants dr dt when the diameter is 50 centimeters. And so you're given r equals 25. All right, so this is, you have to know the volume of a sphere formula. So the volume of a sphere is 4/3 pi r cubed. And notice we have dv and dr, dv dt, dr dt, and those are the only two variables. So it's going to be just like number 1 and number 3, where I just solve implicitly and substitute what I have in. So let's take the derivative of this function, of the volume function. Dv dt is equal to 4 pi, bringing the 3 down, 4 pi r squared dr dt. Now I have dv dt, that's 100. This is the when part now. After I take the derivative, this is when I do the when. So 100 is equal to 4 pi, and then the radius is 25 dr dt. 25 squared, sorry. So, all right, we have dr dt then is 100 over 4 times pi times 25 times 25. So I'm just going to leave that like that because it helps me solve it better. So that's equal to, I'm going to do this together and this together. That would be 100, right? So those would cross out, 100. So it's 1 over 25 pi. And hopefully that is the right answer. Let's put it in units though, because this is a rate and it's centimeters. And remember up here when we were given the volume, it was given in seconds. So it would be centimeters per second. All right, so that's number 5. Let's see if we can do one more. Okay, here comes our famous water tank, number 7. There's an inverted cone water tank. Water's being pumped into a rate of 2 meters cubed per minute. So that means that's the volume. So dV dt given is 2 meters cubed per minute. And that also helps us with our units. Okay, it says find the rate at which the water level is rising. So that sounds like it wants, so this is the have, and it wants dH dt. When, okay, and this is the after the derivative, the tank is h equals 3. When h equals 3, the tank is 3 meters deep. Okay, the height of the water. So they give us that the tank is 4 meters high and the radius is 2 meters. So we can set up, well, first let's write our volume formula down and I'll show you. So volume of this tank would be 1/3 pi r squared h. Now, the problem with this formula is that we have an r and an h and a v. So we have 3 variables. And in order to do this, we need, unless they'd given us other information, like we have dV dt, so that's going to be taking the derivative of that. And we want dH dt, so that's going to be taking the derivative of that. And we know what h is. So this r is our oddball for this particular problem, so we need to rewrite this formula with no r. And how I do that is using similar triangles from this height and width, height and radius that they gave us. So what we say is that we say the height, which is, or let's go the radius first. Radius is 2 over 4. Height, this is, height over radius. Radius over height, is equal to r over h. Okay, and so then if we want to solve, and it would work no matter which one. If we wanted to solve for r, it would be 1/2 h, and if we want to solve for h, it's 2r. So we want to solve for r. So r equals 1/2 h. So now we rewrite this formula back with that information. So I can now say v equals 1/3 pi. Instead of r squared, I use 1/2 h squared times h. And let's simplify this out. It's 1/3 pi times 1/4 h cubed, or 1/12 pi h cubed. So this becomes our new formula that we are going to take the derivative of. So let's go ahead and do that. I'll choose a different color so we see we're on to the next step. So I have dv dt equals, taking the derivative of this, 1/12 pi, and then times 3. So let's just bring that 3 up here. That would be 3/12 pi h squared dh dt. So there we go. Now we substitute what we have. We have dv dt. We know that's 2. And we have h, when this is all supposed to happen, is 3. So this would be 3/12 pi times 9 dh dt. Okay, so let's put this back. That would be, well, first of all, this 3/12 would be 1/4. So that's 9/4. So 2 over 9/4 pi would be dh dt. And so that would be 8 over 9 pi. And so we sit in there, we're going to go 8 over 9 pi. So let's use our this is dh dt, so it would be meters per minute. The answer key that was given on the last page of your homework had it in decimal form, so 0.28, I think it had meters per minute. But that's the same thing as 8 over 9 pi. So that's number 6 and number 7. Or 5 and number 7.